wasn't gonna work with the partner, but then he asked, and I would be like, no.
Alright, so 9.1.1, new chapter. Now, I have news that you guys,
Might not like
you might think is good, or you might just be like, meh. So, I found out that this Friday, we are not going to have math class.
What?
Instead, you will be having connections because Mr. Hall will not be here. He's taking his daughter on a college visit. And
That's
it's
fun.
hard to trust a substitute math teacher or even trust that you'll have a substitute. So, Miss Smith is going to teach connections instead of you guys coming to math, which means that even though you come to me, we're just going to take 8th grade math on the schedule, so there's nothing awkward with connections or whatever else. So, what that really means, we are going to do your Chapter 8 test next week, Monday, Tuesday, since it's like the awkward 2 days before Discovery Day. So, what that also means... No, it's quarter 3.
No,
Chapter 7 isn't even quarter 3. What is quarter 3 is in there. I don't like to stack grades and try to play gotcha. So, like, you don't have Chapter 7 back yet, it's quarter 4.
Like, what's wrong? Like, he'll turn
Yeah, but sometimes it's the most. So, all that to say, I don't like Monday assessments because they catch people off guard. So you need to make sure that you're ready, not only to take the test, but to turn in your practice work. Write your notes and your practice and everything. End of the chapter, at the test day, we're turning in stuff. Some of you guys still need to turn in Chapter 7 practice work and stuff for me, which is really good that it's not for this Discovery Day, because about half the class still needs to turn in their Chapter 7 practice.
I'm proud. Yesterday I was able to finish all my Chapter 8 stuff that I needed to do, and it was like half an hour, and then more working on the science stuff.
This is where we're headed, this chapter. I like the visuals that they give us here to show those different segments. If you're curious how long things are going to take, they're pretty much all going to be one-day lessons. 931 is a longer lesson. 941's a longer lesson. So it's going to take us about 2 weeks probably to do this chapter.
Is there only like 13 units?
Or are we doing all, are we, like, not doing all the units?
No? Why wouldn't we?
Well, I don't know. Usually we don't go through all the units.
Well, so our goal is to cover everything.
But we might, like, not finish chapter.
Yeah, I'll start cutting things out as I need to. So, get out the resource pages from yesterday.
Oh yeah, we're doing step 1.
Oh, we are?
Yeah.
But how many,
I'm sorry.
I mean, it's about an average of one section a day. So units depends, I don't know what you're calling units, but it also depends, each chapter is broken up into a different amount of sections. So there's not really any definitive. If you were to really try to rationalize, it's probably about 4 lessons per week, if we looked at an average. So if a quarter is 9 weeks, we probably get through about 36 lessons, whatever that breaks down to for chapter ones. Alright, so this chapter is going to help us. I love the word manipulate. Learn to manipulate functions so they're useful in a wide variety of situations. Today's lesson focuses on collecting data. Notice the scale over there. We have 1, because I didn't want to steal a bunch of Mr. Cupilo's scales. We can share. And then we're going to generalize results, making predictions beyond the range of data we have measurable, because once we see trends, we should be able to use that to make predictions. Your goal is to determine what is the relationship between the radius of a disk and its mass. So, if you double the radius of the disk, does the mass also double? To answer these questions, we are going to collect data. So you need scissors. I'm going to go steal some more from Mrs. Actually, I'll probably just have you guys go steal them so we don't have to take a whole bin. Or I might go grab them, not sure. But we will need those resource pages from yesterday. And we are first going to cut out the largest circle. And then keep shrinking.
Did we predict? Oh, we did that afterwards. Okay.
So cut out your big circle, then we're going to measure the radius. You'll need a ruler if you want to grab that. I'm going to grab some more scissors because I don't
Here, I'll grab
like
scissors.
child scissors
He's
back.
getting scissors.
Give me 2 seconds.
Oh, really?
Okay,
Oh, really?
What'd you get?
How can a ruler pierce the heavens?
probably can if it's like made of a holy letter.
Oh, well,
Pierce the heaven.
No, he said the ruler will pierce the heaven.
okay.
Measure the radius.
Scissors. Let's make sure they get back into that basket so I can just take it back for. Yeah. I think there should be an actual one sitting right there in the bin.
Ooh, color.
The HSM2 bin.
Oh, yeah, there is. Cute.
Why is it?
If I were you, I'd work metric because it's easier.
Alright, centimeters.
Yeah, because as we get now, if you lay your ruler on there and you realize like, wait a minute, this spacing works really well for inches. You could do inches if you want, but I always will give the advice of working metric because it's easier. Not in ever. That's not like a always true. That's just my general blanket statement.
Why can't we just change our country to the metric system?
Well, we tried
Because
and
we're
failed.
American, we just have to be different. We're like that edgy teen who's like, no, I'm different. I'm an individual in this society.
Yeah, just like all the other people claiming they're an individual and they're different and they have.
Every other country laughs at us because we're so different.
Everything about us is weird and dumb. It's strange.
Well, okay.
There was some meme, and because you guys are just cutting, we can just chat and waste time there. There was some meme about like goth kid clubs or goth kids club for those who don't belong meeting on Tuesday.
I love that.
What?
Because so
It's a
like
beast of
so
point.
the whole gothic movement was like, and it really happened way back before you guys, but it was like, oh, I'm so sad, everything's terrible, the world's everything's
Yeah.
so it's still around, right? But those kids would often say, oh, we don't belong, we don't fit in anywhere. So the joke was there's like a sign for like goth kids who don't belong, club meeting on Tuesday. Get it? You make a club
That's what's so
for
funny.
people who don't
People
belong.
make clubs and they're like,
You
we
think
don't
they
belong.
belong.
They're like, we don't belong in any clubs or any groups, yet they have a group based on being not in a group. And Mr. Allen was talking about
Yes,
goth
we
kids
did.
in our class for social studies once, and he said, you see them, and when you visit, they say, that's part of my life that I regret.
Now make sure, because these rulers are kind of funky, that you actually start at the 0 mark, not the end of the ruler.
Is it fine if there's a little bit of bubble?
I mean, you're just measuring the line.
Okay.
That'll affect your mass a tiny bit, but
Okay.
yeah. So measure radii out to the lines.
Exactly 3.5 inches.
Well, then maybe inches will work better here.
Wait, but I can multiply that by 2.54 and then get centimeters.
If you want. I mean, you don't have to work in metric. I was just saying a lot of times metric is easier because it is smaller broken down.
Where should we record it?
Make a data sheet. Yeah, just make a
We
table.
have 16.6.
So I will make a table up here.
16.6.
centimeters.
Are you measuring the diameter?
No,
Yeah.
radius.
Right.
Radius.
No, it's
Oh wait, no, I didn't do the radius. I did the diameter.
So it's 8 and
8 and 3
Wait.
So our radius, you said the outer one's 3.5 inches, which we can look at
8 and 2 tenths.
metric if you want.
yeah.
I got 2 tenths.
What is it?
Around 8 and 2 to 3 tenths.
Oh, centimeters.
8.4.
So we could also work in millimeters then, couldn't we, if we wanted? So instead of doing like 8.2, wouldn't it just be like 82?
Yeah.
Or 83 or something? So if we wanted to work in whole numbers, 82-ish?
No, it's 80.
Wait, 80, oh. What?
84.
I got 3 tenths. She
Wait, no,
got,
it's just 2. Never mind, I'm stupid.
she got 2 tenths. I got 3 tenths. So it's like slightly off.
How many millimeters are in a centimeter? 10, right? So if you have 8.2 or 8.4, what, just bump your decimal. So should I go in the middle and go 83? Or what?
Yeah, that's about
I got 8.
Do the math. If you're done measuring, go mass.
8.2.
Oh,
82.
mass this.
Okay.
This circle.
I'm going to say 82 to 84 because I don't want anyone to be mad at me. That's how you appease right there.
Thank you.
What'd you get?
By measuring.
1.6 grams, or what's it measuring it?
Grams, I think. Yeah, grams.
Yes, they are.
So, hold on. Get a couple more masses. Check if yours comes out to be 1.6 or close to that.
Yep.
Yeah. Then, because everybody doesn't need to mass it, then start cutting smaller.
I got 1.5.
But
1.5.
it's an estimate.
But I also got like 80
Yeah, 1.6.
millimeters. I got only 8 centimeters.
Oh, never mind.
Are you sure you didn't cut to a smaller
It's
circle?
not
might-
3.5.
I didn't cut to a smaller
This is
circle, but
almost
like I might have cut a bit inside the line.
Okay. So, all of these, we're going to say, are slightly approximate, because obviously there's some human error happening here.
So now do we just cut this big one out?
3 and 3/16.
Now, if you want to, like, skip over, like, you can go way smaller. If you, like, if Ava's going to go the next line, you go 2 lines down. Like, if you guys want to partner like that, you can.
Partner like that, Ava?
Sure. The mass.
Okay, did you do one down already?
No. Do you want to do one down or one?
I'll do 2 down.
I'll do the smallest.
Now, if you cut accurately, you would be able to then piece pieces together if you don't lose any of the paper. I'm just making conversation. You could work backward from the smallest one and cut a disc and add the disc onto it and add the disc on. You know what I mean? Like just the, like not a whole disc, but just the, like the donut. You'd be adding on a donut to make it bigger, but you'd have to cut perfectly.
Yeah.
You know, like cut straight in a radius and then cut around the circle, cut around the circle.
Here, I'll measure the smallest one.
0 line.
So, again, approximate, because there's human error. So, I'll change my 82 to 81. I mean, some people were getting up to 84. Colin got 81, and I agree with his measurement, but again, approximate.
Excuse this interruption. Could I please have Delaney to the office? Delaney?
I got this one.
Circumference and area.
Oh my gosh.
Yeah, that's too easy.
You're cutting. This is not bad cutting. It's
All right.
Slight bubbles. That is fine.
So, we're not going to trust Owens.
No,
Definitely.
look how fine
Oh.
this is. This is not bad.
This is
You're
the
so
smallest
judgy
one
about
is
it.
0.2.
So, wait, what was your radius?
The radius I got was 2.4 centimeters or 24.
So, 24 millimeters?
I got.
And this is,
0.2 or 0.15 because it keeps going back and forth.
so it can't decide.
Yeah, I can't decide.
I got 64 tenths.
I'll do the next, the smallest.
64 millimeters. And I'll do mine.
Wait, what do you get for the measurements? Sorry, yeah.
74 millimeters.
Okay.
1.4 grams for the mass.
1.4.
Yeah.
So wait,
Wait, which one
are
is
you
that?
the next circle in? The next, the
Yeah,
biggest?
I'm the 2 one.
What's your radius?
74 millimeters.
And your mass?
1.3 is settled to 1.3.
Okay.
That's what
Okay. Okay, now I got just one period.
One decimal.
One
What was your
decimal.
radius?
Radius was 64 millimeters.
Alright,
You
I'll
can
cut
do
it.
the next 2 ones in.
Okay, so you go 1 and I'll do 2?
Yes.
Wait, if you go 2 from where you were and you go 1
I
from
got.
where
Oh
you
yeah, those
were, you could be
small.
on the
I
same
got the
line.
third
Yeah,
smallest.
count lines out.
Yeah.
Okay,
Just
let's
decide
go.
based on counting
Just
lines
look, this
out.
is what mine will be in.
So you're
I'll
going
do
to
like
do
one
1, 2,
small
3,
one.
4, 5. You're cutting on 5.
Alright, we
Or
got
you're
another
cutting
one.
on
Actually,
5.
you go first.
So
Yeah,
you
I
guys
should go
all do
first.
two.
Yeah.
No,
Okay.
so she's
I
already
won
done
one.
it.
Wow, I actually knew it.
Mr. Hudson, we
Mr.
got 2
Hudson,
more.
We have 2 more. So the second smallest is I got 28 millimeters
28?
Yeah, that's what I got too.
and 0.2 grams.
Alright, and then we've got the third smallest. It is, let's see, 3.6
What?
centimeters.
Oh, 36.
Yeah, 36 millimeters. And 0.3 grams.
Yeah.
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 Is anyone doing the fourth smallest?
That's what I'm doing.
Oh,
Like line number 4, you mean?
the one up from the one.
Yeah.
So if you count out your first circle, we could call line 1. If you want to make sure we're kind of all talking the same.
Okay. What?
Okay, so this is 4.8.
So you're on line 4 or 5.
48 millimeters.
The
I got
small. It's the
4.9.
smallest that hasn't been done.
So
I got
line 4,
4.9.
quote unquote.
You're wrong.
Alright, what do you got? Sorry, what was your radius?
Radius was
49.
no, actually 48.
Actually, it's 49.
I got 49.
2 against 1. Ha.
I got 0.5
Considering we're
grams.
working at all even numbers so far, I'm just going to take the even number because. And you said what, Ethan?
What? I got 0.5. Alright.
That can't be all.
Wait a
Wait,
minute.
does
I
it
got
fluctuate?
0.6 now.
Wait, is it
Which one is-
fluctuating?
No, it's not.
Yeah, like it's
Take your hand off of it,
That's
dude.
what I'm doing.
57
Okay.
millimeters.
Just one more.
Wait, you guys did the
Okay,
same.
now I'm getting 0.6.
Well, let's see, this is the same.
Oh,
0.5.
Okay,
Yeah,
now it's
still
0.6. It changed to like 0.6 now.
So,
What'd you get?
0.6.
Yeah, 0.55.
0.55.
Wait, let me see your
Word.
Is that really what your 5.5 is
No,
what
it
you
was,
guys want?
0.6.
It's
You landed on
6.
6.
It was 5, but then we both got 6 after a bit.
Sometimes things need to settle. So there's like air stuck between it.
Okay, I'm guessing that you guys are all doing.
I'm getting
Yeah, I know.
49.
I'm like, I might as well not try.
I got 49.
Okay, I mean, we're close.
I got 50, so, but that's still close. So.
Yeah.
I'm curious if there's some ruler error.
Still
Like if one of the
possible.
rulers is goofed
I
up or something.
also it's sad.
Did somebody get the 57,
I'm
Max?
just doing that one.
I'm doing that right now. It's 0.8. 0.8?
Now.
Yeah, I'm just gonna change this to what everyone else says.
So, what do we think would happen if we doubled the radius?
Wow.
Let's see.
Colin, thanks for raising your hand.
Oh wait, no, I was thinking area for a second.
Is that wrong?
I was thinking area.
Is that wrong? You stopped yourself. I'm guessing you think it's wrong.
Well, no. I mean, it's not technically wrong. It's just not really. It doesn't have anything to do with question.
Doesn't it?
This is in terms of radius and mass.
Wait.
I'll find the area instead of all.
Wait.
The area would be multiplied by 4 because we're doubling the radius.
How does mass happen?
Well, there's more of the thing.
What do you mean more of the thing?
There's more volume, I guess.
Okay. I mean, it's very hard for us to conceptualize, but this paper has volume, right? And actually, the stock of a paper can kind of tell you volume because that's how thick it is. So literally, stock could help us figure out a volume problem. Or you could take an entire ream of paper, like 500 pages, and work it down from there.
Oh, jeez.
But so that's the easier way. You can't measure one piece of paper, right? Hey, while we're on this, just let's have this conversation for a second. You'd have to have a very, 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 very precise measurement tool to measure one piece of paper. However, measuring 500 would be easy. Or sure, 500,000.
Yeah.
So from there,
All
from there, because we know we'd have a proportional relationship, we could work it back to a single sheet.
I believe that it is the same as the ratio between area and perimeter. So, like when you double the radius, you quadruple the area.
Wait.
The mass.
If you look at the 24 to the 48,
Yeah, it's about.
it's
like
a 4 times. It's quadrupling, which
yeah.
is 2 squared, which is the same rule.
Yeah, and it also works
Like
with,
Eva said.
it also works with tripling. It's 9 times. Well,
Well, it's not perfect because it would have to be 72.
Oh, it's 1.2. It's 1.2 grams. He makes it work.
So what are we noticing?
Well, no, that has to be 1.3, and then the 74 would be 7.
Yeah, okay, so if this was 72, but then that would be 1.2, right, to
Yeah, that's how it works.
quadruple?
That's what I'm
Yeah,
saying.
as Ethan said.
That's the same ratio as the radius to area.
It's the same rule, because as Colin said, it's area. Guys, your mass is derived from your volume, and your volume is derived from your area. And your area has the relationship we already found. Radius, scale factor, squared.
So could you work backwards?
What do you mean?
Could you work backwards from this and find the like the height of the sheet of paper?
I mean, so you'd have to know that you had uniform paper, like it's all the same weight, it's all the same whatever, and then yeah, I mean you could. As long as you know certain parameters stay the same, then yes. Alright. So, domain and range. We all remember domain and range, right?
Yeah.
Input and output. So, if we think about shrinking targets, what is the domain and what is the range? Sorry, I'm getting ahead of myself. So, sorry, we need to model a function. We forgot to answer all the questions. So I got excited and wanted to move on.
What?
What? I'm sorry. We need to write a function.
I wrote
No, we don't. Oh.
Do you know how to plot data? You have your
That's what
other
I'm
resource
doing,
page. Grab your other resource
So
page.
should we do that now?
Yeah, let's practice this. Make sure that we're comfortable.
Wait, where's that?
Oh wait,
Anyone need this?
About program.
Anyone still need this?
Edit. Go up there. Press clear.
Save this, by the way. This is a really good paper.
We go up. We go clear. Perfect. And then can we just enter our stuff?
Yep.
Right. Can we just graph it?
Plot it is what we call it when it's plotting points.
Well then, what do we press to make it plot?
Yeah, you go to graph. But you have to make sure you turn the plot on, because technically it's called plotting, not graphing. I mean, you're graphing the points, but it is plotting.
So how do you do that?
Did you turn stat plot on? Go back to the, oh, just go graph. So you need to turn the stat plot on unless there's a
Well, how do you turn?
Okay, so I love when you get angry and you haven't followed directions. So have you done all of this?
No.
And no getting angry at me until you do all of it.
I'm confused because I have the sets of data entered in one and two, and when I check my plot, it says that it's like set in one and two. So when I check graph,
Now, the data that we're plotting is the 20s to 80s, 0 to 1.6. We're going to need to modify our, guys, you're going to need to modify your window here.
Okay.
You're
What
going
the
to
heck?
need to modify your window.
So is this
Second white.
Yes,
I
absolutely.
did it! Wow, it looks like it's semi-exponential.
did it!
Looks kind of exponential.
Enter terms.
Yours looks.
Here.
Yeah, yours looks.
Press one.
Yeah,
You
you
had
never
different
got
numbers,
it.
I think.
And delete.
No, I just did these ones.
Yeah, but it's divided.
Well, slightly different numbers.
Yeah.
Why?
Oh.
Yeah, I think we just had slightly different.
That's neat.
Can I recycle
So-
my? Can I recycle these?
How could we actually write a function for this? I'm trying to be very patient and just give you guys a bunch of time to play with this. But how, so start messing with that. If you are plugging in your y equals a function that will fit your plotted points.
Isn't there a way to do this on the calculator?
There is, but we don't know that yet.
I just forgot how to do it.
Yeah, me too.
There's a few different, but it all comes back kind of to linear regression in a way.
Yes.
That was what you probably remember from Math 1, the linreg.
Yeah.
But
It looks like a split.
But we're trying to set up a function not from the calculator giving us exact numbers. We just need like a relationship function, right? So if we wanted to determine the I don't want to do this too much. What would be input and what would be output?
Radius and mass.
Okay, radius and mass. So my domain, my input is my radius. So radius is going to go in, and if we throw it back to the old school function machine, radius is going to go in, and what's going to come out?
Mass.
Mass. So we have to figure out what machine makes that work. What is our f of x? Times 3.
Can't the calculator tell us that? Or
Random guess there.
You're saying mass is 3 times the radius. That
Yeah.
seems
sure.
incorrect.
I think it's right. Times 1.
Wait, it can't be
So you keep saying times. So you're saying the mass, what you're hypothesizing is mass will be something times radius?
No, I think you guessed it.
Okay. I mean, if we want, we could change our units and work in centimeters or even meters. That'd be awkward. It could be awkward. So, think to yourself for a moment, is this going to be linear or is it exponential? We're going to leave this question hanging here for a minute.
Ooh!
Did you figure it out?
No. Getting close though.
What?
Getting close though.
Are there any limiting factors here? Like if we look at B,
It
This-
can't be less than 0.
so we sometimes have to restrict them, right? Say this function is a good model when positive radius, obviously, right? We can't have a negative radius.
Yeah.
Well, if mass is our output, then it just happens on its own, right? If I square my radius, then that'd be working towards area. Is there any like factor? I'm messing with you.
Yeah, you already know, but you're pretending that you don't.
You always shows that.
So this is something I learned from Mr. Cabilo. A couple years ago, students were commenting how his class was fun because he acts like he doesn't know anything, and sometimes they don't actually know if he knows. Like, they're not sure if he knows where they're headed or not. And I was listening to them talk about it, and I was like, really? My goal is just to support you in your learning, right? So there's been a shift in education to be more of a guide on the side as opposed to a sage on the stage. I'm really just here to put your stuff on the board. It's really you guys doing the learning, right? So I don't want to give it to you because that's your discovery. Talk to Neil Gupta. He was like pushing that, but that's like nationwide. There's a shift.
So I have a quick idea, because if it's going to be exponential, then
I didn't say that.
I'm just saying.
Okay.
Hypothetical.
If it's gonna be exponential.
If it were or if it is.
Okay. But you'd have to add 63 because the 1 squared is just 1, and 1 to the anything power is 1. So.
What if we go less than 1?
Okay. Well.
I'm just asking the question. I don't know that it makes it fall apart. I'm just posing the question.
I think this would work, but you have to add 63. If it is exponential, then the addition, like on the end.
So what are you thinking? So you're saying f of x is the mass. You said something about add 63 to what?
Well, like the mass of the x.
Oh, the mass is going to be x? So mass is going to be your input and output is going to be radius then?
Yeah.
Okay, so we're switching input-output then. According to Ava, which we're not saying right or wrong, we're just playing.
It's just easier
So,
to work with smaller numbers.
Radius, radius will be, what'd you do?
X to the whatever power, or x to whatever power plus
Okay.
63.
Well, if we just have whatever power, that's tough.
Yeah,
And is that an exponential function then?
No, it's a quadratic.
quadratic.
That's quadratic, right? Exponential has the power as a variable. Or exponent. Yeah, I said it right the first time. The power is the variable, but a variable as your power is what I meant to say. So interesting. That's not exponential.
I know.
So your statement would have to be something to the x to make that potentially what you're... Because to the first power of something just stays the same. Okay, interesting.
So I was trying to play with that and see if I could come up with values that would make.
Okay. Sometimes it's hard to force fit, right? Especially since our measurements, like we collected the data and then like presented to us. When you put this in your calculator and you used L1 and L2, what did you, like what was your X and what was your Y? When you set up your, like was radius your X then? So here, radius is your input, according to what you typed into your calculator.
Yeah.
Right? So that would mean mass has to be your output.
Mr. Hudson, how do you get cubics on calculators?
Oh,
You can either go through the math menu or you can raise it to the 1/3 power. Remember, fractional powers are your roots. But in the math menu, there's an actual cube root button, or a cube root selection, not a button.
Your cube root, x root, whatever you
not really.
A lot of stuff.
I mean, if we think in centimeters, do like, I mean, if that helps us with our thinking.
it's smaller on the graph. I don't really see anything that's helpful in the long run.
Wait, how can we work with 2 different like measurement like types of
They have to switch them all.
units? Don't we have to
So there'd be some multiplying factor or something that
like
converts.
grams
goes.
and milliliters aren't the same. Like,
Right, so our multiplying factor or something that we use is going to convert. So it'd be like grams per millimeter or millimeters per gram. There's going to be some kind of unit conversion in there.
but will that be like in our equation without us having to worry about it?
That's up to us to figure out.
Oh.
I know. Sucks. Can you make a guess equation?
Well, I know it's not just a number up to the x.
Okay. You know it's not just a number to the x because
I tried it.
we know the proportionality relationship here, right? Like as we doubled our radius, we quadrupled our mass. Can I keep using it? Okay. So what then?
So 0.0375.
Hmm. I don't know if that really helps me.
Wait, is this gonna have anything to do with the will we use? Like, can we do oh, sorry, are we gonna like?
Take a moment. I want you to think without me talking, without anybody talking. Just think and try to write out a few ideas for what could work. Did you guys steal things from Mr. Combs that you weren't supposed to take?
No,
It's just my heart.
we didn't do anything that we were supposed to.
Yes.
This sounds like
There are the green
It usually is around like
Like
0.15.
Right? Our mass is smaller.
Can you compare millimeters to grams?
Well, it's numerically, right? I mean, we can just look number to number, but not, we're not actually making direct comparison. Yeah.
Is this? No, that's over here.
What were you gonna
It's
ask?
not completely off.
Well, I kind of mixed it up because I know that the cube, when you do that equation, the cube it goes like whoop, and that's a weird shape.
What is it?
No, like the cube equation where it goes.
No, like you put like.
You're talking about cube root,
Yeah,
or things being cubic.
the cube where. No, it's the one
Just say
like
X cubed.
equation where it's like x cubed and it goes like.
And it goes like.
Yeah.
So if we were to graph x cubed,
I don't know exactly what it is. I just know that there's some equation that does that. Yes, they do. When you graph it on your
graph it.
calculator, it goes.
We're almost out of time, so I think I'm just going to leave you sitting on this one until tomorrow. But if we look at cube real quick, x cubed, where's my caret? That. Is that what you're talking about?
Yeah.
Now, differently, the cube root of x,
Ooh.
What is x to the x?
Yeah, that's what I'm talking about.
right, 1/2, because square root, we can't square root negatives.
Is it
Cube
possible?
root, you can cube root
Wait,
negatives.
what if you do negative? What if you do negative x to the 1/2?
Negative x to the...
or to the
What do you
negative
mean?
1/2.
This is just going to flip your function. Right, a negative coefficient flips our function.
Yeah, but
Negative
no,
1/2.
do that with the half.
To the power?
Yeah, to the power.
Negative half to the negative power?
Yeah.
Or negative positive
Yeah,
x
what's
to the-
that?
Oh, well. Never mind. Never
That
mind.
looks right.
That looks.
What
Oh,
is
that
x?
looks
What
right.
does x to the
Right
x
there.
look like?
Right there.
What
It's a little
is
further.
What about that to the negative?
Looks about right.
What? X to the x.
That's
the X.
It like goes down.
As the base gets higher, the power gets higher. That's why it goes so steep so fast. As you approach,
Can we hit 1?
as you
No, that's not
approach,
1.
as like, what? As x equals 1?
No.
No, like where is 1 on there? In the graph.
It's
Where's
not 1,
y
1.
equals 1?
It's 1, 1.
Oh, that's true. Never mind.
Yeah, 1 is right here.
Yeah.
Yeah.
Why does
That's
it
why I
not
was-
one
What
down?
about x to the x?
Because, think about it, these are less than 1.
Oh,
Base
yeah.
value is less than 1, power is less than 1. Alright, we're totally out of time. I'm going to pick this up tomorrow and see if anybody was able to figure out a model for our data, or like
I
our
don't
function.
want to work on
Really?
that.
Please make sure your calculators get put back.
I got it in the calculator.
And I set this
Oh, wow.
That happened.
I wonder if it's all the whole
Oh, yeah. Never.
No, that's not.
Graphs make fun.
Try to make X.
Graphs have noises. To the, just do everything to the X as many times.
That 1-1 always exists though, right?
Yeah.
If we keep just doing X powers. Alright, you guys gotta get out of here.